This video will give a brief recap of the factors that can affect the rate of a reaction, as well as showing you how I did an investigation at home to examine the effects of different factors on the rate of a reaction. Let's start by giving a short overview of collision theory. According to collision theory, reactions occur when reactants collide with sufficient energy to form products. This energy is known as the activation energy. Only successful collisions, so collisions that have sufficient energy, yield a product. The rate of a chemical reaction is how quickly the reaction occurs. Different reactions occur at different rates. Reaction rate measures how quickly reactants are used up or how quickly products are formed. If you're measuring the mass of product formed or reactant used, it's often measured in grams per second. And if you're measuring the volume of product formed, then it can be measured in centimeters cubed per second. The rate of a reaction can be affected by various factors that affect the frequency of successful collisions between reactant molecules. Increasing temperature increases reaction rate. This is because when temperature is increased, kinetic energy of particles is increased. Reactant molecules therefore collide more often with more energy, so collisions are more likely to be successful. Increasing concentration also increases reaction rate. This is because when concentration is increased, the reactant molecules will be closer together. This means that collisions between reactant molecules are more likely to occur, and there will be a higher number of successful collisions. The same principle applies when your reactants are gases and you increase pressure. The reactant molecules become more crowded and collide more frequently, yielding a higher number of successful collisions. Increasing surface area of a solid reactant also increases reaction rate. If the surface area to volume ratio of a solid reactant is increased, more reactant molecules will be exposed, so the frequency of collisions again will increase and there will be more successful collisions. Finally, adding a catalyst increases reaction rate. This is because adding a catalyst lowers the activation energy of a reaction, which means that a higher proportion of collisions will be successful because they will have more energy than the activation energy. I did an experiment at home to investigate the effects of different factors on reaction rate. I was interested in the reaction that occurs between vinegar and sodium bicarbonate or baking soda. In this reaction, sodium bicarbonate or baking soda reacts with the acetic acid in vinegar to form carbon dioxide, water, and sodium acetate, which dissociates in the water to form sodium ions and acetate ions. In my experiment, I wanted to determine how vinegar concentration affects the rate of the reaction and how temperature affects the rate of this reaction. First, I needed to find a way to measure the rate of this reaction. One of the products formed in this reaction is carbon dioxide, which is a gas. This product will bubble up out of the solution, which means that the decrease in mass of my solution equals the amount of carbon dioxide that's produced. In my first experiment, I wanted to investigate the effect of vinegar concentration on reaction rate. So for my experiment, I needed kitchen scales, 2 measuring cups, 2 small dishes, a timer or a stopwatch, sodium bicarbonate, vinegar, and water. First, I needed to have a more concentrated and a more dilute solution of vinegar. For my first one, I just used the vinegar that came in the bottle, so I measured 100 milliliters of vinegar into 1 measuring cup. This was my more concentrated vinegar. In order to make 100 milliliters of a less concentrated vinegar, I measured 50 milliliters of the vinegar and 50 milliliters of water into the other measuring cup. I measured 15 grams of sodium bicarbonate into 2 small dishes. Next, I added the sodium bicarbonate to the concentrated vinegar and measured the change in mass of this solution over time. I did the same procedure to the more dilute vinegar and added the sodium bicarbonate and then measured the change in mass over time. My results showed that the reaction progressed far more quickly with the more concentrated vinegar than with the more dilute vinegar. When I plot my results on a graph and then add lines of best fit, you can see that the reaction rate is higher with the more concentrated vinegar. Even with my kitchen scales, which were not very precise, I was able to see that there was a difference in reaction rate. From my results, I can conclude that increasing reactant concentration increases reaction rate. This is because, as reactant concentration increases, the chance of successful collisions increases as well. For my second experiment, I wanted to investigate the effect of temperature on reaction rate. For this experiment, I also used kitchen scales, measuring cups, small dishes, a timer or stopwatch, sodium bicarbonate, vinegar, and a bowl of warm water. I used the same procedure for measuring reaction rate as I used for the previous experiment, so I used my results from my previous experiment as my control condition. So my control condition was 100 milliliters of vinegar reacting with 15 grams of sodium bicarbonate at room temperature. I also wanted to see how increasing the temperature would affect the reaction rate of this reaction. To do this, I made a water bath. So I poured some warm water into a bowl, and then I placed a measuring cup with 100 milliliters of vinegar into the warm water. I let it sit for a few minutes so that the temperature of the vinegar would increase. Then I added 15 grams of sodium bicarbonate, and I measured the change in mass of the solution over time. Here are my results for this reaction. When I plot these results on a graph, you can see that the reaction progressed far more quickly at the higher temperature than at the lower temperature. Again, I've added a line of best fit to show the progress of the reaction over time. From my results, I can conclude that increasing temperature increases reaction rate. This is because increasing temperature increases the kinetic energy of the reactants, increasing the likelihood of successful collisions. My kitchen scales might not be the best equipment for carrying out this experiment, but you can see that even with imprecise equipment, I was still able to show that increasing temperature increases reaction rate. Overall, my results are exactly as predicted. Increasing reactant concentration increased reaction rate, and increasing temperature increased reaction rate. Thank you all for listening.